I'm going to talk to you about CatBoost. I will give you a brief overview of what is the library. Then I'm going to talk about the usages of the library and about the news that we have, including text feature support. You have some samples for which you know the correct answer. And you want to train a model which will give you the correct answer for new samples that the model has never seen. And for this particular problem, there is a long list of different algorithms that you can use. They include linear models, neural networks, gradient boosting, and many others. So how to choose? The simplest rule is the following. If you have unstructured data like sound, text, or images, something like that, then you use neural network. And if you have structured data like table data, where the features are some numbers that are built by some humans, then you use gradient boosting. How does gradient boosting work? Gradient boosting works with decision trees. A decision tree is a binary tree which contains different nodes, and in every node you have a question. Is my feature greater than some value, or some other question about the feature that you have? And then you go to the leaf of the tree and there is a number or an answer. Gradient boosting builds an ensemble of decision trees. First it builds just one tree, then the next tree improves the training error, and then you do this for thousands or tens of thousands of times, and then you have the model that can predict really well. So that is gradient boosting. Why you should use gradient boosting for tabular data? The main reason is that it gives you state-of-the-art results in many cases. On every major conference, there are papers where people are trying to beat gradient boosting with neural networks, but this is still not solved. So because of that, gradient boosting is used in many production in large companies. It's also used in machine learning competitions or on problems where you have tabular data. It's also super easy to use as opposed to neural networks where you need to be an expert, you need to understand which architecture you should use. So it's super easy. You have a Python library, and you feed the model using a simple function feed. And it also works very well with small data. That is gradient boosting. There are several options in open source that you can use. The most famous ones are XGBoost, LightGBM, and CatBoost. They are all in open source. They are all different. So the XGBoost one is the most famous one because it was the first one. The next one is LightGBM. It was open sourced as a faster analog of XGBoost. Then we open sourced CatBoost. And what are the major differences of CatBoost from other libraries? So the first difference that usually people who start using the library appreciate is that it gives really good results without any parameter tuning. So you just train the model, and from the first time you get good results. The next good thing about CatBoost is that it supports not only numerical data, but it also supports categorical data, and now it also supports text data, and I will tell you about text in details later. Also, it has a long list of ways to analyze the model for different modes, in different settings. And it also has different visualizations and snapshots and things that make your life as a data scientist easier. Those are the things why we are using CatBoost. Now, CatBoost is an open source for about 2.5 years. It has about 50,000 PyP installs per week, so that means that a lot of people are using the library. It has almost 5,000 stars on GitHub, and I encourage all of you to go to GitHub and give us a star if you're using the library. We had 64 releases. That means that every month we have several releases. Every month we have a major release with with some new features. So yeah, you should follow our releases and read what are the news. Okay, now I will tell you about usages of this library inside Yandex and outside of Yandex. First of all, it's used in Yandex everywhere. Yandex is a company that has a lot of products, and all of them are powered by machine learning. And where we have machine learning, we usually have both neural networks and gradient boosting. And other things also, but gradient boosting is used in many places. First, recommendation systems. We have Zen, which is which is something that recommends you what would be interesting for you to read. like the posts. Then there is a music recommendation feed. Then there is film recommendations and other things. Then there's self-driving cars. You probably heard, so you know that you have here in Tel Aviv also Yandex self-driving cars. They have test drive on the streets. And they are using not only neural networks, but also gradient boosting, which is a little bit surprising for many people. But yeah, so the vision stuff is done by neural networks. But then for some classifiers, you need to combine these vision features with other features and make a decision. Then there is a bunch of other things, and I will mention some of them, which I think are really important. The first one is search. We use gradient boosting since 2009, I think, so for a really long time, and our search feed is built by gradient boosting. Here on the slide, there is some information about that, including the mode that we are using. We are using our ranking mode, Yeti rank pairwise, and actually in CatBoost there is a long list of different ranking modes that we are using for recommendations and for things like search and for things like personal assistant also. It's used in search. Also, Yandex has a weather prediction service. Here on the slide, you see prediction of weather for Tel Aviv for today and for this week. And we use CatBoost to predict temperature, wind direction, cloudness, pressure, and all the stuff. So for everything, you have your own gradient boosting model. It's also used in our personal assistant for different things. For example, it is used to understand what does the person want. There is a list of binary classifiers. Does the person want to listen to the music? Does the person want to watch a film? Things like that. That's called intent classifications. It's also used in chit-chat mode. So if you are chatting with our personal assistant, it also uses gradient boosting. And there will be the third talk where you will hear about that in a lot of details. Yeah, so gradient boosting is used in personal assistant also. And it's used in many, many different places outside of Yandex. For example, it's used in Netflix for recommendation feed. It's used in Aviv sales, which is a large Russian company to buy flying tickets or hotels. It's used for hotel ranking there. It's used in Cloudflare to detect bot attacks. It's used in CERN to classify particles in a Large Hadron Collider, and it's used in many, many other places also. So those are the examples where you can use gradient boosting. Okay, now about the details and about the news that we have. So CatBoost works with numerical features. It's really easy to work with numerical features if you have decision trees. You have your numerical feature, then every node has the question, is some feature greater than some value? And then you go left or right, depending on the answer. So all the libraries, all gradient boosting libraries do support numerical features. Yeah, so we also do support categorical features. What is a categorical feature? Categorical feature is a feature which has a value from some set of values. And there is no order between those values. So how do we work with them? And I will not go into details about that because I already told about that on last meetup. But I will tell you important things to understand the text stuff that I will talk to you about later. So what do we do with categorical features? We do several things. We do one-hot encoding, which probably all of you know what is it. Then we calculate numerical features based on the categorical feature. So we had this categorical column, and instead of this categorical column, we produce several numerical features. That is the next thing that we are doing, and we are also calculating new numerical features based on different combinations of categorical features. So if we have several categorical features, then we look on the pair of categorical features, and we build a new numerical feature on top of that, or on 3 categorical features. So that is how we deal with categorical features. Now, the important detail here is how we calculate those numerical features, except for one-hot encoding. So how we do that? Basically, let's say you have one categorical feature, which is occupation. And for example, it has two different values, SD and PR. So you had your categorical feature. Your new numerical feature is the average label value with this categorical feature in the data set. It could work that way, but it really doesn't because it leads to overfitting. For example, if you have just a single sample with this category, then your new feature value will be just equal to your label value. So you have overfitting here. What we do is we do it in an online fashion. So for a particular sample, number I, when you are calculating the average of your label values, you are only looking on the samples before this one. So that is the online calculation of the feature. We will do the same for text features. So as you can see here, what we are doing, we are calculating new feature value for our sample number E. It has categorical feature SDE. Now we are looking on all SDEs before this one, and we are just averaging their labels. And that is our new feature value. So it's that simple. There are some details about, like you are adding some priors here, and we are making some permutations of the data set, and we are using several permutations. But the main idea is we always calculate features online. We never look on the label of this particular object when we are calculating feature value. We only look on the previous ones. OK, so that is the categorical feature support. Next thing is text features. So currently, starting from like a couple of releases ago, we do have text support. Now what you can do, you can have a data set where you have numerical features, categorical features, and text features. And you just pass it to CatBoost, and you have your model. How does it work? Well, we have our text, and we extract from this text the words, and based on these words, we calculate a set of numerical features. Like with categorical features, we had a categorical column. Instead of the categorical column, we have new numerical features. Now, instead of text column, we also have new numerical features. For example, so what are text features? That is not super obvious, except it sounds super obvious, but it's not, and I'll explain now. So one example of the dataset where you have text features is the famous Rotten Tomatoes dataset, where you want to predict what is the rating that some reviewer gives to a movie. There are numerical features, for example, how long is the film runtime, or how much money did it make. Then there are categorical features. For example, who is the critic who was writing the review, or where was the review published. And then there are text features. First, there is the text of the review, which is a text feature. And then there are also features where you have a list of categories, For example, genres, or for example, genres. The genres feature has, it contains several categories. And with this feature, you can also work the same way as with text. You cannot work with it as a categorical feature, because a categorical feature needs to have one value out of a set. And here you have like a list of words, which is text. Or a sequence. So that is something that we support now. How useful is this? It really depends on the data set, and it depends on how important is this text column. In the example of Rotten Tomatoes dataset, if you just train the model on numerical and categorical features, then you get out of the box, you get the accuracy 0.459. If you add bag of words to that, which you actually can do with your hands. So you add bag of words with unigrams and bigrams, then the quality improves a little bit. And then if you also add online features, so if you just use CatBoost out of the box, the quality improves more. And the important thing is you get this for free. You just say that this is a text column. Okay, so how does it work? It works in several steps. The first step is you have your text in your text feature, and you extract words from this text. So then you have the words, and you only select the most important of them. After that, you look on that words, and you calculate numerical features from these words. And then you use these numerical features in decision trees the same way as you use all other numerical features. So, yeah, now a little bit more details. So the first part is tokenization, where you are splitting your text. By default, you do it by space, but you can choose any symbol to split it. Then you are doing number processing and punctuation processing. You can, like with numbers, you can change all the numbers to a single token and all the punctuation to a single punctuation token. Or you can remove them from the text. It's done during preprocessing. Then after that, you have a list of words after the tokenization. And it's also lowercase and all the stuff. After that, you have a list of words. And you select most frequent of them. So you throw away the ones with, like, that are one time in the whole data set, something like that. Or you throw away super rare ones. And instead of the super rare ones, you either throw them away like totally, or you change them to some token that is one for all the rare words. You also build bigrams. And if you want n-grams from them, you can also work on character level, where you are building character n-grams. And yeah, after that, you have a list of tokens, like my words, my bigrams, my character n-grams. And from them, you build numerical features. What are the numerical features? So the first and the simplest one is called bag of words. By default, we build bag of words from word unigrams and word bigrams. You can change that in the settings if you want. So what is bag of words? Probably everyone knows that, but I'll repeat. So we first build a dictionary that contains all the most frequent words and all the most frequent bigrams. Then you look on your text and see which ones are present in the text and which ones are not. For example, the word yesterday is not present here, so it's the first feature is 0. The word petrified is present, so the second feature is 1, and so on. So it's just a set of binary features. The next feature is a little bit more tricky. It's called naive bias. So if I'm solving the classification problem or multi-classification problem, what I'm doing is for every class, I'm introducing a new feature and my new numerical feature for my text. And my new numerical feature will be the probability of having this class given my text. For example, if I'm solving the rating problem, let's say the answers are good, bad, and average. So my new feature values will be the probability of having a good review given this text, the probability of having bad review given this text. And you calculate this using naive bias. So that is just using frequencies of the words in a particular class. Then the important thing here is that if you would be using naive bias using the whole data set, then you would have overfitting the same way as you had with categorical features. So what we are doing, we are again doing this in an online fashion. So when you are calculating a feature value for some particular sample, you are only using the samples before this one. So you are never looking into the label value of this particular sample. That's the second numerical feature that we are calculating for this sample. It's not one feature, it's a number of classes, so it's several features. For each class, you have a new feature. The next one is called BM25. We calculated for multi-classification problems. And here again, you have a new numerical feature for every class. And this feature tries to understand which words are the most important ones for this class. So what is the most important word? A most important word that is the word that you have seen many times in your text. For example, if my review has many times the word good, then the word good is important. But you want to penalize the words that are frequent in all the classes, like the, in, or, things like that. So you penalize the words that are used in all the classes. So BM25 is like a modification of TF-IDF. And an important thing here, again, is that we also calculate this online. So for every sample, we only use the samples before this one. That is the next feature, online feature that we are calculating. And basically, in the current version, we calculate those things. They are calculating during preprocessing, but it's important to understand that what you can do during preprocessing and put in the dataset is so you can calculate bag of words. The online features that we are calculating on several permutations, the same way as we did with categorical features. And that is something that it cannot really be done during preprocessing. It can only be done inside the algorithm. So that is something that is calculated inside the algorithm. Okay, so now you know that if you say that I have a text feature, then it can be used in the algorithm during training. It can be used efficiently, and I will get some improvement from having a text feature in my dataset. But it's not all text support that we have in CatBoost. Actually, all the preprocessing that includes tokenization, creating the dictionaries, like the dictionary of unigrams, of bigrams, of character n-grams. Also, we have BPE, that is the algorithm that selects the most frequent character sequences of different lengths. And that is a very efficient thing that can be used in text generation, for example. All of that is available in the library, and you can use it separately from training. So you can use it with as a preprocessing for training a linear model or for training a neural network. And those things are the production things that we have in Yandex. They are super fast. The implementation of BPE algorithm in particular is the fastest one of all the ones that I know. It's also very customizable, so you can choose what you want to do with punctuation, with numbers, with everything. It's also production ready, which means we have things like you can create this dictionary, and then you don't have to write it to the file. You can write it to the memory, and in production use it from the memory. So things like that, and it works super fast and in multi-threaded mode. And I encourage you to try this even outside of just having gradient boosting training. So just use these simple two classes. They have very easy interfaces, and they are super efficient and very useful. Okay, then there is the next thing that we are currently working on. That is not yet in open source, but that will be in open source in one of the future releases, is the support of embeddings. So what we have now, we have numerical feature, categorical features, and text features. What is missing? The text features, the support that we have for text features is built is using frequencies of the words in text. But it doesn't use the sense of the words. And that is something that we get if we start using embeddings. The thing that we are doing is in one of the next releases, you will be able to say that those 100 numbers, that is an embedding that I trained somewhere else. or I used some ready embedding, and that is what I get for my text or for my image, whatever. And then CatBoost calculates online features for this embedding. And we already have this inside. We are working with that, and it gives a quality improvement, including, for example, this Rotten Tomatoes dataset. Okay, now a little bit more about other new features that we have. This talk is mostly about new things. So I'm not introducing everything that we have in CatBoost. I'm introducing some new stuff. So here is the list of what we have new. One new thing is called parameter tuning, which we now have inside of CatBoost. You can use sklearn, grid search, or random search, but you also can use it inside CatBoost. Why you should use it inside CatBoost? Because it's faster. Because some of the things that you are like some of the things like some part of preprocessing that is done many times if you are using external library is done just once if you are using CatBoost, and that is much faster. Also, we are supporting visualization, so if you are doing parameter tuning, you can see what with which configuration of parameters, which quality you have. You can see this on the graph. We are also now adding snapshots, which is super useful if your parameter tuning takes a lot of time, then you know that you will not lose any information during parameter tuning if you are using snapshots. So those are the reasons to try parameter tuning. We are also improving this all the time, so yeah, you can try this. Next, we have implemented, in recent time, we have implemented a list of things that you can try to improve the quality of your training. One thing is automatic learning rate selection. We had this for binary classification before, but now we have added automatical learning rate selection for multi-classification, for regression. And a good thing is when you start to train your model, you can not type the learning rate and have the default learning rate as the starting value. Then you can adapt it, but you can start from it because it's a pretty good value based on your dataset properties. Then we have implemented different regrowing strategies. So one of the differences between LightGBM, XGBoost, and CatBoost is how these libraries are building their trees. CatBoost, by default, builds a full binary symmetric tree. So it cannot get very deep. And on every level, you have the same features. So yes, if you look on the second level, and the left one is feature 1 is less than 0, then the next node will be also feature 1 is less than 0. Then XGBoost also builds full binary trees, and it prunes them, but they cannot get very deep because XGBoost builds a full binary tree, and LightGBM builds it node by node, so the trees can be very deep. What we implemented is we implemented all growing strategies. So if for some reasons you try other library and it works better, what you can do, you can set the growing strategy in CatBoost to this to whatever library there was, and you will get the same thing in CatBoost. Usually, not symmetric trees work well if you have one-hot encoding or if your data has no noise, like for example, it comes from physical simulations. But there might be some other cases where you need not symmetrical tree. We also have a separate support for golden features. Sometimes you have like one feature which is super important. That is a very good predictor of your label. And if you have this, then what you can do is you can say, for this particular feature, make a large quantization. By default, you have like a quantization of 256 or 128 for all the features. And then you say that for this one particular feature, make me a quantization for 1,000 and something. Yeah. Or, you should not use it for many features. You should use it for 1 or 2 features, maybe. Yeah. Okay, then we have implemented new sampling that is called minimal variance sampling. There is a NeurIPS paper about that. It improves the quality. It's there out of the box. And we improved different modes. So you should always update the library. Sometimes there are improvements in speed and in quality. We have improved a list of modes, including MAE and quantile regression. We also, in one of the next releases, will be available the very requested feature that is called local quantization. Many people having a problem that if you have a huge data set and you want to train on a single machine, then there is an out-of-memory error. And that is a problem. You cannot train on such a huge data set. What you can do, you can compress the data set and then train on it. And basically, we are doing that in Yandex for a long time, but it's not available in open source. And we are planning to open source it in one of the closest releases. And if you have a server with 8 volts, so with many GPUs, then you will be able to train on a data set of hundreds of gigabytes on a single machine. And we do it a lot. We use distributed training for not so many data sets, actually. So we do use it in search, in ads, but most of the data sets we train on a single machine because we have this compression of our data set. And that is something you will be able to do in one of the closest releases. Then we have added a list of new analysis tools for your model. For example, there is a mode where you can look on your feature, for every feature. You can see when this feature changes, how does my label value change with this feature? And how does the prediction of the model change with this feature? And how many samples are in each? So you are using some splits that you are putting in the decision trees, like feature value is less than something. And these splits are dividing the feature into buckets. And you can look how many samples of the training data set or of your test data set are in every bucket. So you can look on these graphs. There are also, we have also implemented new types of feature importances. It is possible now to visualize the trees, to plot the trees that you are producing. And we have a new mode for ranking analysis if you are doing ranking and you want to understand why you have this particular order in your ranking. We have implemented new languages for applying the model. I think we currently support everything that people ask from us to have the model in production. And we have done a long list of speedups in the recent times. Some of the speedups are like 10s and 20 times. We have implemented sparse data support on CPU, on GPU. It's also coming very soon. So yeah, and we have done a list of speedups. Please update your library if you are using some old version. New versions will work faster. And with that, I want to finish my talk. And here on this slide, you can see the list of places where you can go if you want to find information about CatBoost. We have our site, we have GitHub. We also have Twitter, and in Twitter we are announcing our releases. So if there is some new release, then there will be information about that. We have 2 chats in Telegram. In case if you are using Telegram, then there is one Russian-speaking and one English-speaking chat where we are answering the questions and users of the library are chatting with each other. Also, I highly recommend to join ODSAI. If you are using Slack, there is a very large data science community. It has around 40,000 people. There are different channels about everything, so it's not our community, it's just the community about data science. And we have a channel that is called CatBoost there, and we post news about the releases there, and sometimes people are asking questions, we are answering them, or someone will answer and help you. It's unfortunately mostly Russian speaking, but there is a lot of English, a lot of information in English also. And I think that's the biggest community in the world of data science in Slack. With this list of resources, please remember it, go to all of them. And I think I have a few minutes for questions now. I have 5 minutes for questions. Yeah?
First of all, do you plan to add Spark support as well?
That is also a very requested thing from us. The thing is, because we are not using Spark in Yandex, or not using it a lot, that is not something that we need to do for any of the teams inside. That is just something that we need to do for open source, and we need to prioritize this. If there is anyone who wants to work on Spark and contribute, we will be really happy to assist you with that. And at some point, we definitely will add this if no one will help. But I cannot tell you the dates now, because that's not yet on the concrete plan.
You said that there is, given an embedding of the text, you run text manipulation, like the
Yes, so that is not open sourced yet. What is in open source now is the frequency-based online features. The embedding-based online features are not yet in open source, but so what we are adding is different online features that are using this embedding. That is also something that works for multi-classification. So for multi-classification, again, for every class, you can have a list of online features. An online feature might be, for example, what is the distance from this embedding to the center of the class, where the class is all embeddings with this, with good review. All embeddings with good review, the center of the cluster, and the distance to that. Then you can calculate this in an online fashion.
Sorry, but then you embed, like you take one continuous embedding and then you embed it again?
We are not calculating embeddings. Embeddings is something that you need to calculate on your own using your favorite neural network library. And then we are just using this thing. And then, instead of the embedding, we calculate a set of online features. So yeah, for example, the distance to the cluster, or there are some other ones also.
Are there any recommendations for working with multi-time series data with CatBoost? I mean, for now, like we need to extract features.
Yeah, so the only recommendation here is you need to do some feature engineering to make the data set for gradient boosting. That's I always have this question, and that's the only answer that I have.
Question that actually continues what you just said. I'm interested about your opinion. How much would you say regarding a data science project, like how much you divide the percentage between hyperparameters and choosing the algorithm and everything, and basically building the data model and feature engineering and all of that? If you need to divide, basically say 20, 80, 30, 70.
So it depends on what problem you are solving. If you have some raw data like images or something like that, then you spend most of the time to try to tune your architecture of the neural network. And if you are working with with search or tabular data, then most of the time you are building new features. So it's yes, the parameter tuning or training of the model is something that you can automate, and then you have the team of people who are thinking of new features.
Is there any difference between the online encoding of features during train time and during test time?
Yes, so during training time, you do it in an online fashion because you don't want to overfit. So for every sample, you only are using the samples before this one in permutation. But when you are, but in the test time, you are using the features that have been calculated on all training data set. And for all test features, it's the same.
Is there a smallest sample size for a small category?
Sorry?
What is the smallest advised sample size for a small category?
So it depends on the size of the data set. And if your category is not very popular, if there are a small number of samples, then the prior that we are using will play more role. And if there is a lot of samples, then you will not see the prior at all. And what we are doing is we are having several priors, and the algorithm selects the feature with the best prior, which so this best prior works best for those features where the prior is visible, which means where you have a small number of samples with this categorical feature.
Is there a number?
No, there is no number. So if you have like a single value, you will just have the prior. So it will not be that useful. The more samples you have, the more information you add there, but it will not break anything. So if you have categorical features that you use just once, it will not break anything. One thing, though, that you will, one bad thing that you will have is your model will grow because all your categories that you have in your data set, you will see them in the hash tables, which are saved in the model. So your model might be very big. And one of the ways to reduce the size of the model is to remove those not frequent categories, which maybe do not really give a lot of new information to your model.
Are there plans to introduce feature constraints on numeric features, like monotonic features?
Monotonic constraints are, that is one of the things also that we have, we do implement, we have implemented them.
For sometimes numeric features, they become very jumpy in CatBoost.
Numerical features?
So numeric data, if you don't have data for the whole range, sometimes in the middle the model will jump and give crazy predictions.
No, we don't do anything for that right now, and I don't think we plan to do anything with this. But if it doesn't work for you, then you can send us a data set. We can look why it doesn't work. If it really doesn't work because the features are behaving in a weird way, then maybe we can get some insight from that.
Do you have the data augmentations, some support for that built in, or you just, if you want to do your augmentations, you're doing it before and then send it?
Yes, so if you have any data augmentations, you do it before, and then you produce new features, you give it to gradient boosting.
You said that there is online settings with online for each sample. But what happens when the first samples are not?
So if you, for the first sample, you just have the prior. So there is a, like with categorical feature, for the first sample, it would be not the average label of all the values, but you will have the prior there in the nominator and the denominator. And we use several priors, so you do not really have one feature, you have several features with different priors to address this problem that you are talking about. That for first samples, there is not a lot of information, or for samples that just are rare, there is not a lot of information.
Any last question? Okay.
Thank you very much.